Hey there. This is the second post in my series on evaluating LLM-powered products, part of my ongoing effort to rediscover what data science means in the AI era. Subscribe my Substack, Data Science by AI, to get updates. I'd love to hear your thoughts, experiences, or even disagreements. Drop a comment on my Substack posts or reach out on LinkedIn. Let's keep learning and figuring this out together. Coming from a statistics background and years in data science, my first thought when asked to evaluate a model is to look at accuracy, or related metrics like precision, recall, or F1 score. So when I began working with LLM-powered products, I naturally asked, what's the accuracy? But that quickly led to a trickier question. What does accuracy even mean in this context? In traditional ML, accuracy is simple. If the expected output is true and the model predicts true, it's correct. But AI products aren't that simple. Take this example. If the user prompts, "What's the temperature today?" we expect an output 110 degrees Fahrenheit. Yes, I live in Arizona. And the AI responded, "Today's temperature is 110. Then this response is factually correct, even if phrased slightly differently. Now consider a more open-ended query. How's the weather today? Shall I go out and play soccer? Here, correctness becomes subjective. The right answer depends on interpretation, context, and tone. There may be multiple acceptable outputs. Accuracy or correctness isn't always the most important metric. It depends on your product. For support bots, factuality and correctness may be critical. But for a creative writing assistant, fluency, tone, or style may matter more. Like any data science project, defining the right metrics starts with your stakeholders. Work with subject matter experts to translate business expectations into measurable criteria. Call it accuracy, correctness, factuality, or faithfulness. What matters is alignment on what good looks like. There are many open source benchmarks for evaluating LLM accuracy, but they are often generic and won't reflect your specific use case. If you're building a customer support chatbot, for example, you want to evaluate responses to your customers' questions, not general trivia or MMLU benchmarks. This requires crafting your own test set. How to measure accuracy. I started with BLERT. Actually, I'm not sure if I pronounce it right. It spells BLEURT and textual entailment, but quickly found their limits, penalizing synonyms, ignoring fluency, and often divergent from human judgments. That's when I shifted to LLM-as-a-judge, also called LLM-guided evaluations. It is using a model like GPT or Claude to evaluate the quality of another model's output. Some teams fine-tune evaluators. Others, like myself, use off-the-shelf models with prompt-based scoring. Tools like DeepEval help streamline this. So a typical setup may look like this. First step, provide the input, model output, and reference. Secondly, ask the LLM to identify factual errors or omissions, guided by evaluation steps or quote-unquote rubrics. The final step is score or classify the responses. Prompt quality matters in LLM-guided evaluations. I can't say enough about the importance of collaborating with subject matter experts to design proper prompts to reflect what evaluators should look like. A sample accuracy evaluation prompt could look like this. Rate the assistant's answer based on how correct it is given the question and the context. Criteria: correctness, score from 1 to 5. Does the answer factually align with the provided context and directly address the question? Step 1. Read the question and the context carefully. Second, check if the answer is factually correct and relevant, and then embed the question, the context, and the answer. This is a very simple example of an evaluation prompt. You'll likely need to tweak this, just like any prompt engineering. There are variations of LLM-as-a-judge. One example is POLL, which stands for Panel of LLM Evaluators. POLL essentially aggregates scores from multiple LLMs rather than relying on a single model. LLM-as-a-judge is easy to implement and increasingly affordable, but it's not flawless. I highly recommend a Substack post from my friend Kriti on how can you trust an LLM to judge another. You can find the links in my Substack post. Lastly, I want to talk about single-turn versus multi-turn conversations. Factuality and correctness are easiest to assess in single-turn interactions, or a golden test set, which are prompts with verified answers. Compared to single-turn, multi-turn conversations are closer to natural human conversations. However, multi-turn evaluations is much harder. It may require full dialogue scripts and ground truth references for each turn, which can be expensive and time-consuming to curate. That's why most evaluations focus on single-turn scenarios. But we shouldn't ignore multi-turn performance. There is a recent research called LLMs Get Lost in Multi-Turn Conversation, which shows that LLMs often struggle with multi-turn dialogues. According to this paper, it reports up to a 39% drop in performance when conversations go beyond the first few turns, as models tend to get lost after early mistakes. Okay, that's all on accuracy for this post. Everything I share comes from the things I've tried and experimented with. I definitely don't have all the answers. This field is evolving fast, and I'm learning alongside everyone else. If you've been working on the same problem or have different approaches, questions, or critics, I'd love to hear from you. Again, this field is moving fast, and the more we exchange ideas, the better we all get at building and evaluating LLM-powered products.